So we have the diagram here for the question as you see on the board, and the question reads as follows. So you get the following diagram and they ask the gradient of the line PQ is. Alright, again, yet another example of a question that we could look at from a paper 1 context and a paper 2 context. Because you will from time to time get questions just like this, very similar to this, in your paper 2, where they actually give you a diagram of an actual line, and in a lot of cases, just as they did here, the first thing they ask you to find is the gradient, or they might ask you to state the gradient. Yeah, and they might give it for 1 mark. So in other words, they're not necessarily looking for a whole calculation here. And what I will do deliberately in this video is that I will approach it from a minimalist standpoint where the calculation is concerned. So we're going to minimize the calculation, because what's the point of a graph? What's the point of a live diagram if you're going to do the same thing that you would have been accustomed doing if you didn't have a diagram? So in other words, they could have told you find the gradient of the line that passes through the point 06 and 30. They could have done that too. In a case like that, you don't need a diagram. But by giving you a diagram, one, it allows you to actually see the points. Well, it's clear that this is the point 06, and I'm going to write them in here just for explanation. This is the point P06, P06, right? They didn't give the coordinates, but I put them in here just for explanation. And this is the point Q, 3, 0. Now, how do I know that is 3 and not 3.5 or 2.5? Well, in a case like this, they expect you to use your common sense. Good. The diagram looks very scaly or scalish, right? Right? And if the line, I mean, you could see that it cut in the x-axis halfway between 2 and 4, right? And halfway between 2 and 4, that can only be one thing, 3. So this is 30 and this is 0.06. Now, from the time you see a line slanting like this, before you even pick up a pen or a pencil to write anything or to shade anything, you know immediately that the gradient is negative. So that means in a question like this, you could immediately rule out A and B as answers to this question, because A is +2 and B is +0.5. Boom, out of the picture immediately. Right? And look at the common sense here now. If you have an idea of what a gradient of a half looks like, if you have an idea of what a gradient of a half looks like, then you would just orient the line in the opposite direction and you get a gradient of -0.5, right? Now, I would have covered that in a separate video in another place, right? Which you could look for and find. Right? I did a whole video series on the gradient of a line, and somewhere in there I would have actually drawn lines of different gradients just to give you an idea of what a gradient of 1 looks like, what a gradient of 2 looks like, what a gradient of 3 looks like, what a gradient of a half, 1/3, a quarter, etc., etc. So in other words, you whittle this down to C and D, and what's the 2 choices? -2 or -0.5. Now, a line as steep as this, there is no way that the gradient of this line could ever be -0.5, right? That is way too steep for a gradient of -0.5. So in a case like that, the only answer that makes sense is -2. Alright? So you don't even have to calculate anything. You know, and this is what I'm showing in a question like this. You eliminated A and B to begin with, because you know the gradient is negative. Now you look at the line, you know the gradient is negative, so you eliminate A and B. You look at the line and you realize, well, okay, if they are saying that the choice is between -2 and -0.5, then there's no way it could be -0.5, just based on our knowledge of what the gradients look like. Alright? But let us assume, for the sake of argument, that you wasn't sure, you're genuinely not sure if it's -2 or -0.5, right? because maybe you don't really have a concept, you don't really have a picture in your head of the difference between a gradient of -2 and a gradient of -1/2, or the difference between a gradient of 2 and a gradient of 1/2. So guess what? You resort to your calculations. You know that if you have a situation where you have the line and they give you the x-intercept and the y-intercept, then all you do is you divide the y distance, which in this case which is 6, by the x distance, which is 3. 6 divided by 3 is 2, and then you take into account the orientation of the line to give you the sign. So if the line is oriented like this, you know it's negative, so the gradient is -2. And these are numbers that you could calculate in your head without writing anything on the paper. Right? Of course, if the line was slanted like this, then the gradient would have been +2 and not -2. So these are little things that you need to keep in mind, right, as you're doing this particular topic of straight lines. Right? It is not always about grasping for a formula. Right? You need to have a picture in your head of what a line with a positive gradient looks like. And you need to also know what a line with a negative gradient looks like. And then beyond that, you need to have a little idea of what a gradient of 1 looks like versus a gradient of 2, or a gradient of 1/2, or a gradient of 1/4, etc., etc., etc. So I'm taking this opportunity once more to encourage you to prepare as completely as possible. It's going to make your life a lot easier in the paper 1 and by extension in the paper 2. So again, by way of repetition, the answer for this question is answer C, -2.